To take the derivative of an exponential function, the derivative of e to the x is just e to the x. Then if you have the derivative of e to a function, it's like a chain rule, so you have derivative of e to the function, just like e to the x is going to be e to the function. But then you have a derivative of the inside function, that chain, so you take the derivative of f prime of x. So for the first example, we're going to find the derivative of the function. The function is going to be 3e to the 3x plus 1. Derivative of e to the 3x plus 1. It's going to be e to the 3x plus 1. And since 3x plus 1 is like an inside function, derivative of 3x plus 1 is just 3. So the final answer for the f prime of x is 3e to the 3x plus 1. For the next example, g of x is equal to 5e to the negative x plus 2. The 5 is just a coefficient, so just writing that down. Derivative of e to the negative x plus 2 is e to the negative x plus 2. It's got an inside function, so derivative of negative x plus 1, x plus 2 is negative 1. And then just rewriting the function, bringing the negative 1 in front by the 5. For the next example, we have f of x is equal to x e to the 2x. You see x in two different places being multiplied, so we have two functions being multiplied together. So we're going to do a product rule where x is the first function and e to the 2x is the second one. Take your g, which is e to the 2x, times your f prime, which is 1, plus your f, which is x, multiplied by your g prime, e to the 2x, times the derivative of that inside function of 2x, so multiplied by 2. And then just now simplifying the problem to get e to the 2x plus 2x e to the 2x, factoring out an e to the 2x that they both have in common, leaves you back with 1 plus, and then 2x from the second term. So f prime of x is e to the 2x times quantity 1 plus 2x. For the next example, we have g of x is equal to e to the x minus e to the negative x all over 2. To avoid the quotient rule, remember that dividing by 2 is just multiplying by 1/2. And if you distribute the 1/2, you can just look at those as being coefficients in front of the e to the x and again in front of the e to the negative x. So when you're deriving, it's not a product or a quotient, but just a coefficient. So the derivative is 1/2 e to the x minus 1/2 e to the negative x being an inside function, also multiplying by a negative 1. Simplifying the problem to get 1/2 e to the x plus 1/2 e to the negative x. Then factoring out what they have in common, notice both terms have a 1/2. And they also have an e to the negative x, that's the smaller exponent. So if we had e to the x and then we took out a negative e to the x, we're left with an exponent of 2x. So the first term has e to the 2x left, and then the second term has just 1. For the next example, we're going to have an implicit differentiation. We have e to the x plus e to the y is equal to x cubed. Derivative of e to the x is e to the x. Derivative of e to the y is e to the y times derivative of the exponent, which is dy dx. And then it's equal to 3x squared. So solving for dy dx, moving the e to the x over, so we have 3x squared minus e to the x. Dividing by the e to the y, so dy dx is equal to 3x squared minus e to the x all over e to the y. Going back to the original function, notice that if we solve for e to the y, we'll get x cubed minus e to the x. So we can replace our derivative to write dy dx is equal to 3x squared minus e to the x all over x cubed minus e to the x. The next example, we have y is equal to the cube root of e to the x plus 1. Rewriting the cube root as e to the x plus 1 to the 1/3 power. Taking the derivative, the 1/3 will come in front. The chain rule will leave the inside function the same. Take away 1 from the exponent to make a negative 2/3 from the new exponent. Deriving the inside will just be e to the x. And then rewriting our problem, e to the x is in the numerator. The 3 in the denominator from the 1/3. And then the e to the x plus 1 of a positive exponent of 2/3 since we're moving to the denominator. So now for the last example, we're going to find the second derivative. For the given function, y is equal to e to the x squared. So getting the first derivative, e to the x squared is going to be e to the x squared times the derivative of that inside function. Derivative of x squared is 2x. So our first derivative is 2x e to the x squared. So now to get the second derivative, we have a product rule from the first derivative. 2x is being multiplied by e to the x squared. So take the g, which is e to the x squared, multiplied by f prime, which is 2, plus f, which is 2x, multiplied by g prime, which is e to the x squared, times the derivative of that inside function of x squared, which is then 2x. Simplifying the problem, we'll have 2e to the x squared plus 4x squared e to the x squared. Factoring out the common factor, taking out a 2 and an e to the x squared. From the first term, you're left with just 1, and from the second term, you're left with 2x squared. So the second derivative is 2e to the x squared times quantity 1 plus 2x squared.